3, 2, 1. Okay, the next topic deals with the limits of functions. We're going to take some mathematical processes that you've learned in the past. You probably won't remember, but it will come to you, hopefully. And if not, just ask me questions, we'll get through it. But I'll show you some of the manipulations you're going to have to make in order for these processes to work. So we're going to look at about 5 scenarios here. First one is the limit of a function as x approaches -1 of x squared minus 1 over x plus 1. Okay? Now, obviously this can't happen because the -1 in the x here gives you 0 for denominator, and that is undefined. But what we can do is come up with an equivalent equation or function, if you will. If we call this, let's say that this is f of x equals x squared minus 1 over x plus 1. And then we factor this right here. This is a difference of squares. Square root of x squared is x, the square root of 1 is 1. And a difference of squares, you get a plus or minus of binomials that gives you this value right here. So this is x minus 1 times x plus 1. All over the denominator x plus 1. And looky here, we've got a cancellation taking place. Now we don't have the issue of the x plus 1 in the denominator. So we can find the limit. Now, how is that possible that we can do that now? Well, you could have before. If you would graph this in your calculator, you would have seen a continuous curve going through that point where x is equal to -1. But technically it's there, but you don't see it. So you still could have figured out, you could have punched out the numbers and gotten all that. But regardless, now we've got a new function that we call a simpler function. And now this is just equal to x minus 1. So we call that a simpler function. And we can grapple with that because the limit is still x is -1, so we plug that in right there. So the limit then is equal to -1 minus 1, which is -2. So fun with math. Let's take another scenario. Now if I go too fast, you can always pause it, but let's take a look. This is kind of the same thing, only now you're dealing with a difference of cubes. And the limit of f of x is equal to x cubed minus 8 over x minus 2 as x approaches positive 0. Well, again, we got the same issue. Put 2 in there, you got an undefined denominator. But we can factor this out. Now, I don't know how much you remember about factoring difference of cubes, but these are both cubable or cube rootable. And this gives us x and then -2. And when you do that, that leaves you a trinomial. And the trinomial is the square of the cube root, which is x squared, the cube of 8, which is 4, and that's positive 4. And then, because this is negative, all these have to be positive, so we know that the next term has to be positive in order to end up with everything all canceling out and stuff. And you take the cube root of that times the cube root of that, make sure it's positive, and that gives you 2x. And that is your factoring of the difference of cubes. Had that been x cubed plus 8, then this would have been a plus here, and that would have been a minus there. Over x minus 2, and again, yay us, we get rid of that nasty, inconvenient denominator, and so that gives us a g of x value of x squared plus 2x plus 4. And now we can plug the 2 in right there, and there, punch that out, and get a 12. Okay? Next scenario. Let's take the limit as x approaches negative 3 of x squared plus x minus 6 over x squared minus 9. That's a 6, not a spoon or a lunar semi-crescent. Factor both of these, see what happens. Because if you make negative 3 here, you can't do it. So let's factor it. Let's find if we call this f of x, we're going to find a g of x that will be simpler, allow us to come up with a limit. Well, what two numbers multiply together give you negative 6 that give you, that when you add them together gives you positive 1. The answer to that is 3 and negative 2. So this is x plus 3 times x minus 2 all over. And here's another difference of cubes. Boy, we see this all the time. X plus 3, x minus 3. You get rid of the middle term, they got to do the same thing, only opposite signs. And again, whoa, look at this. Cancellation. And when we plug in the negative 3 for this, we don't get 0 for the denominator. Yay us again. So this gives us x minus 2 over x minus 3. And so when we put the limit in there, then it's negative 3, so this can be negative 3 minus 2 over negative 3 minus 3. Negative over negative is positive. 5, 6. Next one. Wow, this is a dandy one. I like this one. All kinds of mathematical manipulations here. You got here the limit as x approaches 4 on the square root of x plus 5, and minus 3 is outside of the radical, and x minus 4 on the bottom. Yeah, we got another situation where we can't deal with the denominator in 4. So we got to do a little mathematical manipulation here. Well, guess what? Difference of squares are going to come into play once more. But in kind of a slightly different, this is a little bit of outside the box thinking. This is one of those things that would probably be a good idea if you guys brainstorm on some of these and come up with ideas. Because again, just like physics, there's an answer to all these problems. Except in calculus, every once in a while there isn't one. But for the most part, you can count on that just like physics. And it turns out that if you take the conjugate of this radical expression, and what is conjugate of radical expression? That's where you change the minus to a plus. So this becomes, you know, multiply both the top and the bottom by the square root of x plus 5 plus 3 on both sides. Now, why would you do that? And two answers. One is, why not? The other is, because you know that something has to be done with this to get rid of this. And so we're going to see what happens. It may not work. It's always worth trying. I have a feeling this is going to work because there's nothing else to do. Anyway, so in the denominator, or in the numerator here, you have a conjugate pair of expressions multiplying each other, which means there's going to be no middle radical term. You're going to square this minus the square of this. So this becomes x plus 5 square root x plus 5. Square root means when you multiply that number by itself, it gives you the number inside the radical. So that gives us x plus 5. Negative 3 times positive 3 is negative 9. Over. And then I'm just going to leave this like that, because that's just so stinking messy. I don't want to deal with this yet. And it might just resolve itself. How did I possibly know that? Square root of x plus 5 plus 3. Now, 5 and negative 9 add up to negative 4. So this becomes x minus 4 over x minus 4 times the square root of x plus 5 plus 3. And looky here, we got the x minus 4 canceling out, so that gets rid of that pesky and awkward situation. So now these cancel out to be 1 here, so that leaves us 1 over the square root of x plus 5 plus 3. That's our g of x as x approaches 4. So now, we plug that 4 in right here. That gives us 1 over the square root of 4 plus 5 plus 3. Well, 4 plus 5 is 9, square root of 9 is 3, and 3 plus 3 is 6. So this is 1/6. Now, nice the way that worked out. In fact, I think if you do the graph of that, that's exactly what you get. Okay, last one I want to show you is kind of a precursor to what we're going to be coming up before too long here. This is the limit as delta x approaches 0 of 2 times the quantity x plus delta x minus 2x over delta x. Now, this delta thing we got going on there, it's kind of the same thing as c. It's a difference from x, and generally when they put like a delta x like that, it's pretty small because we're all about as small as possible, trying to get the infinitesimal differences between points. You could have used c, but this is just a little more dramatic flair. So, you know, this is algebraically not too difficult. All we have to do is distribute the 2 across both of these. So we say f of x is equal to 2x plus 2 times delta x minus 2x over delta x. And look what happens. 2x, negative 2x are out of here. So this gives us 2 delta x over delta x, and that rather obscure delta x is no longer going to bother us. We cancel out. So that means the limit equals 2. Okay, so let's do some practice with that, shall we? Page 68, 46, 48, 52, 56, 58, and 60. See how you do with that. And you get stuck, talk to somebody, see if you guys can brainstorm some ideas. Let's start getting the mathematical creative juices flowing, all right? Then if you're totally stuck, I'll be more than happy to help. But try to fight through this yourself first. Have fun.